Hello, everyone. Welcome back to our class. We are now in our week 7, and I'm so glad to see you again. Today, we are going to discuss about the relationship between current and the voltage. Our most essential learning competency for this week, we're going to infer the relationship between current and voltage. Our objectives: number one, determine the relationship between electric current and voltage. B, electric current and resistance. And number two, we are going to state the Ohm's law. Electricity is a part of our daily lives. Many of the activities we do every day depend on electricity. The discovery of electricity changed people's lives. Can you watch your favorite show on TV without electricity? Can you use your computers without electricity? Imagine our life today without electricity. You have been learning a lot about electricity from grade 3 to grade 7. You have learned about its sources and uses. What materials make good conductors of electricity? What makes up an electric circuit? And how electrical energy is transferred or transformed into other forms of energy. In this module, you will learn more about electricity. There are three quantities that you should be familiar with in the study of electricity. These are electric current, voltage, and resistance. Let us first discuss the electric current. Electric current is a measure of the number of electrical charges passing through a cross-section of a conductor in a given time. The direction of conventional current, or simply current, is from the positive terminal of the battery to the negative terminal. The symbol for current is capital I, and unit for current is amperes, or capital A. André Ampère, from 1775 to 1836, he is a French physicist and mathematician and one of the main discoverers of electromagnetism. The SI unit of measurement of electric current, the ampere, is named after him. An ammeter measures electric current. Figure shows how the ammeter is connected in a circuit. The positive terminal of an ammeter is connected to the positive terminal of the energy source or the battery, while the negative terminal is connected to the negative terminal of the energy source. What level of current is dangerous to people? Current in amperes. If you're going to have the 0.001 amperes, effect on the person can be felt, while in 0.005 amperes, the effect on a person could be painful. And for 0.0110 amperes, involuntary muscle spasm is the effect on a person. For 0.015 amperes, loss of muscle control. And 0.070 amperes, if true heart serious injury, likely fatal if it lasts more than 1 second. Voltage. Voltage, the charged electron pusher. Voltage causes current to flow or move. So voltage sources are battery, generator, and outlets. The symbol for voltage is capital V, and the unit for voltage is volts. The symbol for voltage is capital letter V, and the unit volts is capital letter V, is named after the Italian physicist Alessandro Volta from 1745 to 1827, who invented the voltaic pile, the forerunner of what we call now the dry cell. Voltmeter measures voltage. The voltmeter is connected in a circuit. The voltmeter should be connected across the load being tested. The positive terminal of a voltmeter is connected to the positive terminal of the bulb, while the negative terminal is connected to the negative terminal of the bulb. When electric charges flow through the wires and loads of circuit, they encounter resistance, or the hindrance to their movement. So, another factor that affects the flow of charges or current is resistance. Resistance opposes the push from the voltage source. Resistance affects the speed of the current. The symbol for resistance is capital R and the unit for resistance is ohms. The unit ohms is named after a German physicist, George Simon Ohm, from 1789 to 1854. Ohm determined that there is a direct proportionality between the voltage applied across a conductor and the electric current. The relationship is known as the Ohm's law. An ohmmeter is an electric instrument that measures electrical resistance. Activity time! You can go to the PET to have the activity on your own for you to experience the simulation activity. So let us observe as we increase the voltage. What happened to the current? Now, we're going to decrease the voltage. What happened to its current? Now, let us try the resistance. If we're going to increase the resistance, what happened to its current? How about if we're going to decrease the resistance? What will happen to its current? So based from the activity, we conclude that if the voltage in a circuit increases, the current will increase. If the voltage in a circuit decreases, the current will also decrease. This is a direct proportional relationship. How about between the resistance and current? If the resistance in a current increases, the current will decrease. And if the resistance in a circuit decreases, the current will increase. This is an inversely proportional relationship. Ohm's law. It states that the voltage or capital letter V across the conductor of resistance capital R is proportional to the current, capital I, passing through the resistor. German physicist George Ohm had the law named after him because of his extensive research according to Ohm's law. The Ohm's law equation: V is equal to I times R. Voltage is equal to the current multiplied by the resistance. Voltage measured in volts, or capital letter V, and current measured in amps or ampere, capital A, and R, resistance, measured in ohms. Ohm's law equation: for voltage, V is equal to I times R. The unit is volts. For current, V is divided by resistance, or volts divided by resistance, and the unit is ampere. For resistance, resistance is equal to voltage divided by current, and the units is ohms. Let us have our sample problems using Gressa method. How much current flows through a lamp with a resistance of 60 ohms when the voltage across the lamp is 12 volts? Using Gressa method, G for given numbers, so we have resistance is equal to 60 ohms and voltage is equal to 12 volts. Required is we're going to find the current. Equation: current is equal to voltage divided by resistance. Solution: current is equal to 12 volts divided by 60 ohms. And the answer is current is equal to 0.2 amperes. It's your turn. Get your pen and paper and solve the following problems. Each number will be given 1 minute to analyze and solve the problem. Get ready in 5, 4, 3, 2, 1. Number 1. How much current would flow through a circuit that has 1000 ohms of resistance if powered by 1.5 volts? Let us answer the problem. So we have given resistance is equal to 1000 ohms and voltage is equal to 1.5 volts. Required is current. Equation: current is equal to voltage divided by resistance. Solution: current is equal to 1.5 volts divided by 1000 ohms. The answer is current is equal to 0.0015 amperes. Did you get it right? Very good. Now, let us go to number 2. How much resistance allows 60 volts battery to produce a current of 0.006 amperes. Now let us answer the problem. Our given numbers are voltage is equal to 6 volts and current is equal to 0.006 amperes. Required, we're going to find the resistance. Equation, resistance is equal to voltage divided by current. Solution, resistance is equal to 6 volts divided by 0.006 amperes. And the answer is, resistance is equal to 1000 ohms. Did you get it right? Amazing! Now, let us go to the last number. What is the voltage across a 100 ohms circuit element that draws a current of 1 ampere? Now let us answer the problem. Givens are resistance is equal to 100 ohms and current is equal to 1 ampere. Required is voltage. Equation, voltage is equal to current times resistance. Solution, voltage is equal to 1 ampere multiplied by 100 ohms. The answer is 100 volts. Did you get it right? Congratulations! Now you can go to your module to answer other problems. Thank you.